Hi, I'm Frank Lamb from Automation Consulting, and this is a Zoom webinar on Siemens TIA Portal from August 28th, 2020. Okay, no one else is here on this call yet, but I am going to be doing this Zoom meeting. It is 10 o'clock in the morning on August 28th, and today we're going to do some work in TIA Portal. I've already prepared a project that we're going to work in a little bit later, but I'm going to start from scratch here and create a new project just so that we have a recording of exactly how that's done. I'll be creating a formal class for this a little bit later and may use some of this video. So this is the icon for TIA Portal. You can see some other Siemens icons in one area here, and you can see some Allen Bradley icons in another area. Those are the two main platforms that I use. You can see there's step 7, which is the older software. We did a webinar on that last week. And then the newer software is TIA Portal. And I believe they're currently on version 16, which I don't have. So I'm using version 15. It's not very old. It's only been around for probably a couple years. I think I did most of my training on version 13 and 14. And so I just got version 15 not very long ago. In any case, you can either start a project from here, or of course you can go down and find it in Programs, and it will be in your Siemens folder. Right, Siemens Automation folder. So you can start it from either place. Now it does store your files by default in a different location. It stores them in an automation folder, but I'm going to go ahead and start it from the desktop here. So I double click it, and it takes a little while to boot up. It's a little bit slower than step 7 software is, but there are some advantages to TIA Portal over step 7. It's an integrated package. That's probably why they call it TIA, Totally Integrated Automation, because it's all in one package, like Allen Bradley is. So step 7, you could have 7 or 8 windows open without even trying. But with TIA Portal, everything stays within the same box with a couple of exceptions. One exception would be down here. I've got my PLC sim, fake PLC running down here, and that remains as a separate object. But all your hardware configuration and things like that remain within this box. I'm going to go ahead and minimize this as if we were starting a brand new project. There are 2 views. The first view is, I called it sometimes jokingly, the children's view, because it looks like a kind of a wizard, right? So if you say create new project from here, you're still in the children's view. It's actually called the portal view. I'm going to go ahead and create a new project, and we'll just call it web project or something like that, so we can identify it later. And we'll just call it web project 1, and it will go to the last place that you started a project. So the default is a folder, I believe, called automation in the programs folder, and Siemens has a place that they like to keep things, but ideally in a plant you would want to put this in some location particular to your project so that you could find it easily and export it and things like that later. So I have it in here, something called PLC training video webinar TIA, so that I can keep it separate from my other ones. But once I say create, then I'm still in this wizard or portal view, and I'm not going to stay in this very long. The reason I kind of call this jokingly the children's view is because it steps you through all these different things, and I think most people are used to this project view, which is this view. And it's being slow this morning, probably because I have more than one project open. So this is very similar to the way Allen Bradley works, if that's what you've worked in before. I'm going to go ahead and make this about as big as I can without maximizing. And I don't like maximizing because, for one thing, sometimes my taskbar doesn't work right. And for another thing, if I have anything else floating in the background, then I have to go find it on the taskbar. Okay, so now I have an empty project here. I can always go back to the portal view if I want to. But with this empty project, the first thing you need to do, as you would do in any PLC platform, is create your hardware. So I'm going to add a new device, and we're going to add something pretty simple here. I can add HMIs, I can add controllers, and I can add PC-based systems. And you can see here that TIA Portal works with both the newer processors, which are the... Hello, still there? Okay, we're still there. Somehow, I'm not sharing my screen anymore. So I'm going to go back to sharing the screen. Somehow I got disconnected. So I don't know if anybody else was on here and whether they got disconnected, but no, looks like we still have no other participants. Okay, so I'm still in my software. What I was getting at here is that these older versions, this version, does not work with the simulator. So if you want to work with a simulator, you need to pick a newer firmware, and that's what I'm doing here. So now I say, okay. And you can see the little spinning wheel of wasting time. This is common to Siemens and Allen Bradley, of course. But it is creating your little rack here. So you can see everything's contained within one package, but it gets a little tight. They weren't quite as efficient, I think, as Allen Bradley was when they laid this out. But it is a little faster than Allen Bradley. So some of the things that you need to do when you create a new processor, you need to set the Ethernet address, right? I would need to do that. I might need to set up a network, but I'm not going to do that here. And in this case, I'm going to stick with the default because we're not going to actually use this one. I have another project set up to save time. The other project, by the way, the subject that I was asked to cover by someone in my Facebook group today was object-oriented programming. And Siemens has always had something called a function block. And a function block really is an object. It's every bit of what Allen Bradley's add-on instruction is, which is the AOI. And add-on instructions get exported from a project and then imported into a different project. And so that's kind of what they're for. I'm going to make sure here that, for instance, my audio is working. I wish someone was here because they could tell me whether they could hear me or not. But I assume that I can be heard. Okay, so if I am setting this kind of an IP address, obviously this 255, 255, 255 means that everything else needs to be on the same network, 192, 168, 0, something. So my computer would need to be on this same network. Now it's not in this case. My computer's address is 192, 168, 3, and I believe it's 200. So if I wanted to talk to this processor, I would need to change this mask. And this is not necessarily the place for talking about the mask, but suffice it to say that this mask will let 0, 1, 2, and 3 all talk to each other in this second octet. So that's the way these masks work. They work the same way as masks work in PLCs when you are moving data and that sort of thing. But this 252 allows that. So just if you don't want to figure it out mathematically, you can always look at one of my videos on data and math, which I have created, and that would tell you why this mask operates that way. I covered that pretty extensively in that video. But this mask, 255, 255, 252, allows 0, 1, 2, and 3 all to talk to each other. So since my computer is 192.168.3, it can talk to this 192.168.0. Now, in Allen Bradley, the processor does not need to talk back to the computer. So you can leave the IP mask in Allen Bradley the same. I can leave it at 255, 255, 255, and it'll still work. But with Siemens, it doesn't. So very important that you set the mask properly to communicate both directions from the PLC. Now this little 1200 is a kind of a neat PLC. It does not have a rack as such. It just has cards that kind of plug into the side. And you can see the size of this rack. You can put up to 8 more cards in here. And you can put some cards also here on the left. These are special purpose cards, things like communication modules, whatever. And then there's this neat little box on the front. And if I wanted to, I could take one of these boards and plug it into this location. So there are signal boards that'll give you a little bit of I/O. There are communications boards that I could, for instance, put a Profibus board here. And there are battery boards, so I could do a battery backup of my system in case the power goes down or something like that. We are just going to put a couple cards here, and that's just to kind of show you how the I/O structure works. And I'm just going to pick one. Anything I pick, I will get the information for it down here. I'll get a full description. So sometimes you'll see these numbers and you won't know, well, these are both digital input 24 volt. What's the difference between them, right? If I click on this other one, I'll get a different description, version 2.0, version 1.0. So the only difference here is the version number. That's kind of a firmware number. So I'm just going to pick one. I'll pick the newer one. Okay, so it puts it in here. It gives it an address. Now I would have to, again, go browse down and look for my address. You can see here that it put this at I8. So everything in Siemens is byte based. It put it at I8.0 through I9.7, right? Everything's a byte. So byte 8 and byte 9. There are individual things that you can configure for the inputs. You can put little filters on them and that sort of thing. So kind of neat. You can individually change things maybe in the channels. Looks like none of that is changeable here. So this is a pretty basic card. But this is where all the properties are, and you can see your addresses and things like that. Go ahead and put an output card in the next slot. 16-point output card. Again, that would take a couple of bytes. We'll see what the difference is. Version 1, version 2, same thing. This is a DC card, but I also have relay cards. There are no AC cards in here. If I wanted an AC card, I would have to use one of these relay cards to apply my AC out to a motor starter or something like that. The reason that you might choose an AC card is if you are running some of the older conveyor systems, for instance, they have AC coils. Or if I had a really big motor starter, it's hard to pull in a large motor starter with 24 volts. There's just not enough oomph there. So you're going to use your AC for that. So we'll pick this. We'll just grab one. Automatically sticks it in the next location. I can again see my tags. It picked Q12 and 13 here. So you can see the addresses once again, and you can also see them, I believe, over here. So if you really want to see your layout, you can see it here. Picked 8 and 9, picked 12 and 13, and there is some onboard I/O. So depending on which processor you select, you will get some of your internal I/O. We'll see if we have any of that here. I think we do. Just have to scroll up. So you can see it used byte 0 and 1 for the inputs and also for the outputs. So I would be using things like I0.2, Q 1.0, 1.2. Now there's only 14 inputs and 10 outputs, which means your addresses go from 00 to 07, and then from 10 only up to 15, right? Because, or yeah, I believe so. 15. So 16 and 17 are not included in here. Your Qs, you would go from Q0 to Q7, Q0.0 to Q0.7, and then the only other two you would have would be Q1.0 and Q1.1. So you wouldn't be able to use 1.2, 1.3, and so on. Your analog, you have some onboard analog, and it is in process input word 64 and input word 66, and that's what this is all about. So I'm not even going to put any analog cards in here. We're just going to kind of end this here as far as hardware configuration. I'll show you how easy it is to add program blocks. You already get your OB1, that's your main routine. If you want to add a protein block, program block, a protein block, that's funny. Sounds like something you have for breakfast. So I can add different things here. I can add other OBs, right? And they're not numbered like they are in step 7. They do have numbers behind them, but you can pick your hardware interrupt and it'll just pick it kind of by type. You don't want to rename this. You can select a cyclic interrupt, which is typically, again, here in the 30 range, right? I can pick 35 sometimes is all you get in step 7. I can pick one of those. But we're not going to do one of those. I'm just going to go ahead and put a regular old function in here. It is important to name it something, and they have them color coded. That's kind of nice. And we'll call this control. What the heck? And subroutines, which is what a FC is, are very important to segregate your program, right? And even do things like the reusable code that we talked about before. You can see here it's churning, and it's eventually going to create it. There it is. It's open. I can do all kinds of editing and things like that here. Create new tags. Ultimately, the way I would want to create my tags is to go down here and possibly create tags ahead of time. Now, there is a default tag table, and if I open it up, there are already 30 tags in here. But these tags are system constants, right? They're things connected with high-speed counters, hardware tags, things that I might want to use in here, and that's what those initial tags are. Now, something interesting to do, I can go back if I want to my hardware anytime, right? Go back here, and if I double click on this, there are a couple things down here we probably could have talked about before since I was there. I can configure my local I/O here. I can also do things like, let's see if we can find it. System and clock memory. This is what I was looking for. So in the step 7, we also did this. We went in and enabled the clock byte. And in last week's video, I also made manually a system byte for always on and always off. And this was pretty standard for people to do. They would use usually M1.0 and M1.1 or M0.0 and M0.1 for the system memory bits, but here they've given them to you. They kind of built it in, which is useful. A lot of people use always true and always false, and here it was so important that Siemens actually included it. The clock byte is the same one, again, that I did in last week's webinar, and these will be on YouTube, so if you didn't see me do that last week, that was August 21st webinar, and you can go back and see me configure the clock byte. right? We did step 7 last week. So this clock byte, these are just pulses that sit there and pulse constantly, and you can use them for whatever. You can use them for flashing lights. They're a little square wave, and I had to manually create them as far as the names and everything. But here, because Siemens TIA Portal is tag based, it gave it a tag name of clock _ 10 hertz. And I can use that, and I did use it in the other project that I'm going to show you. So by enabling these will show up in your tags. And I'm going to go ahead and save this project again. And now when I go down to my tags, I should see 44 tags. You can see here there's more tags. So if I say show all tags, some have been added. And there they are. See the always true, the always false, all these bytes. And I can use them just by selecting them. I can also create new groups of tags. This is a nice feature. These groups are not really segregated from each other, but they sort of look like they are. So what I'm going to do here is we'll make a new group called System. This is just a folder. It's really all it is. And if I open it up, we'll add new tag, show all tags. I'll just add a new tag down here. And new tag. We'll make it a bool. Now, the only kind of tags that you can make here directly are M tags, I tags, or Q tags. So they're the only things that you can really choose, right? As far as type. So you have a lot more M memory in these 1200s and 1500s than you ever did in the 300s. The 300s, sometimes you'd only get 256 bytes of memory. Here you can say, oh, I want a kilobyte or 2 kilobytes, whatever. Memory's gotten cheap as technology's improved. So we'll just leave this here at M2.0. Anything I create after this is automatically going to increment M2.0, unless I make something like a word. And if I make a word, then it's going to jump to the next available word. And we'll call this word 1. And go ahead and make it an integer just to show you how that works. If I make it an int, remember the difference between int and word. The integer is the thing that you do math with. And we'll just say memory word, and we'll make it memory word 4, which would be the next available whole word. And if I make another word, it should jump to the next available word. Word 2. See, it automatically increments. Notice that word 1 defaulted to MW2, and I could have done that. I could have had word 1 include this new tag, but that probably wouldn't have been advisable depending on what I'm doing, right? So we'll go ahead and show that little group of tags. We'll put these in the system tag. It says default tag table. If I put them into the, let's see, PLC tags, we'll save the project. That may be why this is not showing up. Oh, add new tag table. There we go. And we'll just call it systags. We got to rename it. So this is not quite as user-friendly as Allen Bradley. I'm used to clicking on things and just typing, right? But this, you kind of have to click on things and rename whatever. And we'll just call this systags. Do the names really matter? Well, only for the programmer, right? These are not really separating the tags from somebody else using them or anything. They're just organizing them into folders. And you can do the same up here with your blocks. I can add new group. We'll call it zone 1 group. So this, once again, is not like Allen Bradley's program groups, right? But if I put my zone 1 group and I put control down there, now all of a sudden, whatever I do in control will be in this group. And once again, I can go find it again. Now that we've created this other group of system tags, if I want to, I can move these to the system tags. So this is an organizational tool. You can see system tags has 3, default tag table has 44, and I can say show all tags. And notice that as I open these different things, I'm getting these folders down in the bottom. I still have my control folder open, and I can choose from my available tags, right? New tag. We'll just say, if new tag is activated, then I will move. So I can either do this and put a box in here, or I can choose my functions from here. My move. Okay. When you double click, sometimes you get 2 things. And I could have changed this by selecting move, right? I can select anything from here. So this little box up here in the top means that you don't have to go over to these folders. That's kind of nice. But I'm going to delete this, and we're going to just stick with something very simple. And I'll move word 1 to word 2. All right, so very simple logic here. Once again, I would have to call FC1 from OB1, because otherwise it wouldn't run at all. I'm going to open OB1, show you how that works. So you don't double click on FB1 down here or something. Instead, you drag it like this. So at this point, I would have control called by OB1. Inside of control is this logic. And if I activated new tag, it would move word 1 to word 2. Okay, so fairly understandable there. We're going to leave this project right now and move on to the other project. And we're about a half hour into the webinar now, so this is a good time to do that. When I click, it says, do you want to save the changes? Now, this is different than step 7, once again, because I would have saved all my blocks independently and my VAT tables independently and things like that. This saves everything together. So it's an integrated solution as opposed to step 7. I'm going to say yes. I want to save it. We're going to close it and move on to the other project, which I've already got up and running. So this is our other project. And this has a lot more in it. I actually started this project yesterday. I said I was going to create a new project. I have not created any groups, and you can see that I'm starting to get a lot of blocks in here, and it might have been advisable to put a group in here. So for instance, add new group. I can say motors. Okay, and then I can drag different things into my group. I'm not hurting anything by doing that, right? I'm not changing anything in the program. This is all just for organization. You notice I've got some different kind of motors in here. That's the reusable tag part that someone asked me, and I don't remember his name right now, but someone asked me in my Facebook group to talk about reusable code. And what I decided to do for reusable code was create one block that I called multiple times, and that is this function block right here. And it has instance data blocks, just like we talked about last week, for each motor, but it is just one block that is called multiple times. Now I've got this laid out. This is in alphabetical order. So the reason, just like Alan Bradley again here, The reason that I put R1, R2, R3 is because otherwise they would have shown up in this list in alphabetical order rather than the order in which they were called. So a little bit of an overview of how this works. You can see I already have some blocks and things open here. I started out, this is a 1500 as far as my device. And I think I already maybe had my device configuration open here. Also notice, I just realized I'm already online with this. So I'm using a simulator and I'm online, and everything shows here with these nice little green balls. If I make a change, and I will do that before the end of the class, I'll go ahead and make a change after I'm done with explaining all this. But this is showing everything basically online. So you can see I can go online, I can go offline. If I go offline, all the little green balls disappear. I can't see the status of anything. In here, this is a 1500, and in the 1500, I configured a variety of things. It had some other ports. So for instance, I configured an HMI. I thought it was a lot easier to use an HMI to show what was going on in here than to have to go into the code. So to do all of that and to run the simulator, there were some special things I had to do in the processor. So we've got 3 different tabs up here: topology, network, device. If I click on the processor, I get all the things particular to the processor. I click on properties, and you can see some of the things that I had to set here. One of the things is to run the simulator at all. There were things we had to do in the security. Server certificate, I don't think I did anything there. I did not activate the web server on this module, but what that would have allowed me to do is to drill into the processor and look at its status as a web page, right? It could have been a web server for some of its information, what kind of shape it was in, kind of like looking at the diagnostic table. You could let your plant manager or maintenance supervisor, whatever, look into the processor and see all that. I can see all of the IO tags, which in this case were the clock byte and the system byte that I enabled before. There is no onboard IO, so all of my IO I put over here. And once again, if I want to see my addresses, I can see them here, my layout. So you see how things are kind of tight. Now, one thing you can do, of course, you can close these little sidebars. That can be very handy to hit these little arrows, and that gives you a lot more space, right? And the arrows are always there. So they did do some nice things here. It's still not quite as, I consider it, elegant as some of the AB control logic stuff. But this certainly is better than step 7. You can still do the 1500 in statement list. That 1200 that I did before, you cannot use statement list in. Okay, so this was my hardware layout. I did a couple of input cards. Then I did 1 output card. Maybe I did 2 output cards. Or is that another input card? It looks like maybe it's another input card. No, it's an analog input card. And it used word 4 through word 11. So that would be 4, 6, 8, and 10, right? It's a 4 analog input card, unlike step 7, where I would have had these up in the 200 plus kind of range, right? I would have maybe started at 256 or 800 or something like that. They automatically default. Same thing for my analog outputs. It used some other words here. Use the next available I and Q addresses. And it does much of that for the tags also. But that's pretty much it as far as hardware configuration. The next thing that I did here, I did have an OB1. OB1 called everything else, right? So that's its main job here. I did not need to put my always on and always off logic in here. it just calls all these other routines, and it calls them in order. And this is actually very important that you do inputs before the auto sequence and before the outputs. The faults in the system bits matter less, right? They can be, I like putting my system first because it's easy to find, but it's very important as far as the scan that the inputs come before the auto sequence, which uses the inputs, and then the outputs, which the auto sequence often drives the outputs. So very important that you call this in this order. These other two wouldn't matter, but I like putting the letters here to reflect what order I actually called the routines. And I put some of this stuff down here. I have a system data block that I did not put in the motors, but I put everything that started with motor in the motors folder. So that's kind of a useful thing to do from an organizational standpoint. They're not really segregated in any way other than for your own purposes. They're for the programmer. What else do we have here? Program resources. Sometimes these things are useful. These are the data blocks. They're the actual instance data blocks for things like this timer and all of these timers. And then the data blocks for the function blocks are actually up here. So they kind of segregate them that way. Program resources are because these are IEC timers. IEC timers need data blocks just like they did in step 7. What else do we have down here? We have a data type. I did make a UDT. Data type looks like that. I made a system data type, and this is again something to do with reusable code. So I was asked to do reusable code. By making a UDT, you can actually export the UDT. See if it shows up here. I think you have to go up to maybe tools to export the UDT. But this UDT could be reusable in other projects. So what the UDT did is I went in and created a tag, and that tag includes these data types. It's actually inside of a data block. So we'll take a look and see if we can find the data block. Here it is. This was a manually created data block, which would be a global data block. If I open it up, you can see that the data type is that UDT, it's U system. And if I open it up, there it is. And so my tag name here would be system, sys, and then whatever the element that I wanted to use. And you'll find that in my FC. So the next thing I did was go to FC1. And you can see as I open these, right, it opens them down here on this tab and highlights them. So this is a nice feature, just like AB there. And in this case, so I'm using some of these different tags, and I started right out with a memory tag called HPB Auto. HPB is my abbreviation for HMI push button. I always use this with AB, Allen Bradley, so I also use it in Siemens. It's just my habit. And there's the UDT. So this is system data block .sys.auto mode, system data block.sys.manual mode. And I did the same thing here that I did in last week's system lesson, same lesson that's in my book, Advanced PLC Hardware and Programming. If you don't have that book, it's a good idea to get it. It has all kinds of fun stuff about real auto modes and timers and different things in it. It goes beyond what a lot of basic books do. So here I set auto mode. Here I reset auto mode, right? Reset auto mode and set manual mode. I don't allow that to happen if you're in auto cycle. And then I created a third mode here. And this was just a cute idea, I thought, because on my HMI, it allows me to unlatch both auto and manual mode. Now, once again, you wouldn't want to do this if you were in auto cycle. Okay, and then I did the same thing I did last week, which is if I'm in auto mode and I press the cycle start push button, and I'm not already in auto cycle and I'm not faulted, then I run a timer. When the timer's done, I set auto cycle, and I'm then in auto cycle, and this bit goes off, right? This is my cycle starting bit. Now, what did I do with the cycle starting bit? I actually drove a horn with it. So the horn would beep while you're starting the cycle. I had a little video last week of, and I'll go ahead and show you. This trainer, and when I start that trainer, and I can put it in, there we go, auto mode. And when I'm in auto mode and I have not yet started my system, it blinks like this. And then when I start my system, let's see if it does it. I never remember which button's which. No, this is auto and manual. So that's auto. This is cycle start. There we go. Okay, so now I'm in permanent auto run. So that's the idea behind the system mode logic. So I use this little portable video camera to kind of show what I'm doing. Back to here. Once again, as I explained last week, once you're in auto cycle, you don't always want to be able to simply cycle stop immediately. So if you press the cycle stop push button, it will latch in a cycle stop request. And then when you have a permissive, which I have latched on. So if I monitor this, right, if I were to latch this on, right, if I were in auto cycle and I press this button, it would set the request. And the next time you had the cycle stop permissive, which is currently on, then you would reset auto cycle. So let's take a quick look at how that operates. And what I did for that is I created an HMI. You can see my little simulator here. This is what I'm downloading to. I don't actually own a TIA Portal PLC. So the only thing I can do right now is program with this simulator. I sometimes use some TIA Portal PLCs from Automation Training, the company that I teach for. But here I don't have one. So I want to use this fake PLC. That's how I do my downloading and things like that. And then if I want to use the HMI, which this HMI, we didn't talk about that when I configured everything, but see how this PLC is added? But you can also add a PLC, a HMI here. So I had a PLC, added the hardware for that, then just right clicked and said add new device under my project, and it created HMI1. If I want to start the HMI and simulate it, here it is. So you simulate in the PLC the same way. This is where you can do a lot of different things, but this is where I would start simulations also. I've already started it, so it's not showing up here. And we will start the simulation of the HMI. So I made just a little simple HMI partially to drive things like this. And here it goes. And you can see here, I'm in manual mode, just like I'm in manual mode here. There we go. So I've latched in manual mode, right? I've set it. And I can go from manual to auto using this little HMI. So here's manual, here's auto. And I'm blinking this stack light just like I blink the other ones. Now I did something a little bit different here. I'm gonna go ahead and turn these off. And what I did is I created some buttons that actually turn on the lights, right? So the first thing I did if I wanted to simulate things is go into the outputs. That's where I like to put them. And this is where some of the logic is for the stack light. I didn't use any real I/O here, but I did imitate real I/O with the stack light. So you can see if I'm in auto cycle, my stack light's on permanently green. If I'm in auto mode, then that internal clock blinks and it blinks the stack light. Or if I press this HPB green light, which is the button on the HMI screen. So this is HPB green light, right? So when I press it, you can see that light blink or come on briefly. And also, of course, auto mode, auto cycle, control that. Very simple here. Manual mode turns on the yellow stack light. Also, the push button turns on the yellow stack light. So that's how I'm doing that. Same thing with the red light. And once again, all these are running because I called the outputs routine with my OB1. My system horn or buzzer, while I'm starting my cycle, my buzzer horn comes on. We'll go back and start and go into auto mode, and then I'll talk a little bit about what I did with the motors. There's my touch screen. Go back into auto mode. I'm blinking. My cycle start works much like it did before. There's my horn. Right, you could see it blinked red there. It actually has a little flasher, but your update on your screen is not going to be as fast as a real horn would be. You would get it every scan, whereas I think you get about a half-second update for the screen. So we're in auto cycle at this point. See, it says cycle start, and I just let this indicate my cycle running. And I can still cycle stop because I had that permissive. So we'll go ahead and cycle start again. We'll see if we can see the horn. Yeah, it blinked briefly, but it doesn't really sound like a regular horn. So we're in auto cycle now. I'm going to go back into manual actually real quick here, and I'm going to show you this little motor. So this motor is a single motor, very simple. It runs or it stops. So in the output routine, I believe I did something very simple here. Yes, I did a simple hold-in circuit. Once again, if I push the HPB motor start, which was that start button, it locks this in. If I hit HPB motor stop, it turns this off. So this is a single motor, simple hold-in circuit. But how does reusable code work? So reusable code, I take this same kind of logic here, right? And I put it inside of a function block. Let's see if we've got the function block. Here it is. And what makes this code reusable is inside the only thing you can use for reusable code, and I explained this last week. I did a function block, pretty much the same thing. The only thing that you can use in your logic are these parameters up here. And again, I made a very simple piece of reusable code. This is a typical motor starter. And what I said was, if I look at the logic, if I hit the start command, right, and I don't have a fault, then I am running. If I hit the stop command, right, then I will not be running. This is a hold-in contact, and the reason that it's orange is that typically when you, right, read access to the tag is not recommended, but for a hold-in contact, it's fine. You were not allowed to do this at all in step 7, but it made things very complicated. If you're not changing this byte, right, and I did make this retentive. So, right, this is running and it's retained. So typically things like these inputs, I don't want retentive, but this output, I do want retentive. What you would have had to do in step 7 is declare another static variable and use that for this internal memory bit. But it's extra work, and it's really not necessary in this case for TIA Portal. Okay, so this is basically how this was constructed. It's very, very simple logic. There's not much to it. Used entirely internal variables, and that's why these have pound signs for them. Okay, so that's what makes them reusable or object-oriented. This is an object, and I take that object and I call it several times. So how did I do that? I go to my outputs routine, which is this one. And you can see here would be a typical call to the routine. And my start is my start command right here. And I used an indicator for step 20. And I'll show you how the auto sequence works for this. And then if I hit my, if I'm not in run mode, then it's going to automatically stop this. So you can see that inside of this was just a typical hold-in circuit, and the output for that usually would have been a physical output. But again, I don't have a real PLC here, so I just used an HMI indicator. And then I called the same block, right? This is motor 1. I called the same block again, and that's what makes this reusable or an object. So motor 1, motor 2, motor 3, motor 4, and motor 5. They're all stopped by the same thing. And of course, if I have a fault, they will also stop. They all drive different motors, right? So I'm driving different indicators, but they all start with different things. So they start with step 20, step 10, no step 10, just step 20, step 30, step 40, step 50, and step 60. So they sequentially start. And the way I did that is I used a very simple sequence. I'm going to go back up to my PLC. Here's my auto sequence. It was already open down here. You see I have a lot of blocks open. This is the way the auto sequence works. If I'm in auto cycle and I press the run push button, I go to step 10. If I'm in step 10, I run a timer, and I used one kind of timer here and a different kind of timer below. But this is an on delay timer. When it's done, it goes to step 20. When I'm in step 20, I use a different timer, and when it's done, I go to step 30. So you can see here, I used a different technique. Here I use the done bit like you would do in Allen Bradley. And here I just pinned it directly to the Q bit, 30, 40, 50, so on. If you're in step 60 and you press the stop push button, you will go back to 0. So that's the idea behind that. And then all those indicators, right, that drove, right, the motors are right here. So in step 20, I turn on HIND step 20, which drives the output. That's this. See, HIND step 60, whatever. And each one of these comes on in the sequence sequentially. Let's see how this works. We'll go ahead and go to the HMI again. So the first thing I need to do is go to auto mode. I'm in auto, I'm blinking, waiting for cycle start. I am started. When I hit run, I immediately go to step 10. When step 20 happens, turns on motor 1, motor 2, motor 3, motor 4. I'm in step 60, motor 5 is on, right? All separate calls. So all these were separate calls here. I have turned off the indicators, right? So I'm no longer telling them to start. They've already started. And as long as I don't go out of this run indicator, then these motors are all going to run. And that's what makes them reusable, right? So that is 5 separate calls to the same motor block, FB1, but they all use different data blocks. So that is how you use objects. That's just one way to use objects. There's lots of different things you can do. But this was kind of what I said I would do today. And that is create some kind of object and show a little bit about object-oriented programming. So this was what somebody in my Facebook group asked me to do, and that's what I did. So we'll go back here, run it a little more, right? If I hit my stop, all those go off. So I was in 60 if you press the stop push button, right? And I put different indicators in here. This is not an HMI programming class, but it took a while to get used to doing this again, right? There's a lot of kind of tricks to programming HMIs, and this is WinCC. It's a very nice little program that is included right there in your Step 7 software. It's truly integrated, which is maybe why they call Totally Integrated Automation TIA Portal. It's also integrated in the Step 7 software. That's something Alan Bradley hasn't managed to do yet. So once again, if I run, and I go back into my sequence, running all those individual timers, starting each of these motors in turn. These could have been conveyors. Sometimes people do staggered conveyor starts, and that's how you would do that. One of the things that you'll notice here, I'm going to go ahead and stop this simulation here. We're kind of done with this. We'll stop. Here we go. So you can see how everything looks here, but it will look different on my creation screen. So I'm going to show you the creation screen, and then we're going to end this little seminar here. There we go. See this? This is like a lamp test down here. It's kind of fun. I can do a cycle stop. Go back into blink here. It changed my indicator. All right, so I'm going to stop this. It says runtime's being terminated. So I'm simulating two things here. I'm simulating the PLC, which is this down here, and then I'm also simulating the HMI. So the HMI itself is down here, and if I open this root screen, which is the only screen that I've created, it looks like this. And you can see everything looks fine here. You don't see any scrunched up letters or anything like that. But of course, when I ran the actual simulation, everything was kind of scrunched up. A little bit about how this stuff works. If I click on this, I can go down here to my properties and see all the configurations for that particular button. All right, properties. You have animations, which changes colors, and I animated the appearance to make it light green and dark green. And then you have events, which in this case, there are other ways to do this, but I like press, which sets. I like release, which resets. And of course, you specify the tag that you want to use. To go select that tag, once you've used the tag and it's in here, right, there are internal tags, but you can also, because this is integrated, select your tags from up here. So that was another reason in this case that I segregated my HMI tags from my IO tags and from my tag table. Okay, we're going to stop the sharing there. Let's see my ugly mug here. This is the end of this webinar, and nobody showed up, but that's okay. I enjoyed doing it, and I did get a recording out of it, so I will go ahead and probably post this recording at some point a little bit later today. But thanks for watching this webinar after the case, if that's what you are going to do. And I will be able to use this resource anyway for some recordings and things later, so I don't mind doing it. This is the 4th webinar I've done for my Facebook group, and sometimes people show up and sometimes they don't. But that is it, and see you later.